Hello students, welcome to your Intro to Geometry review video. In this video, we're going to take a quick, brief look at all of the chapters that we have covered so far in this class, and we're just going to try to refresh our memories a little bit about things that we've done for third and fourth quarter all the way back to late January. And so I'm just going to, like I said, sort of fly through the chapters that we did, show you some examples of things that we talked about. Like I said, hopefully it sparks your memory. These will be the things that will be sort of fair game for your final quiz. And just a reminder there, we will have to take a final quiz here, but it will only count if it helps your grade. So as long as you take the quiz, if it helps your grade, I'll keep it. If it doesn't help your grade, I'll throw it out. But I do think it's an opportunity for you guys to improve your grade quite a bit. So yeah, hopefully you put in a little bit of time. Like I said, just sort of flipping back through the book, making sure you remember these things, okay? So chapter 1, we started with really the basics of geometry. We started with points, lines, planes, all those building blocks. So points, remember, were like capital letters denoting a specific point in space. And then we also had lines, we had rays, and we had segments. Those were sort of related to each other, but lines, remember, go forever in both directions. Rays start at one point and go forever in one direction, and then segments obviously have two endpoints and they stop, right? So points, lines, rays, segments, and then the other thing that we talked about early on was planes, which, if you remember, is like a sheet of paper that expands forever in all directions. Once we talked about these basic ideas, we started putting two rays together to create an angle, right? So we talked about angles, we talked about acute angles, we talked about obtuse angles. We also talked a little bit later about different types of angles. So some angle relationships that we talked about here early on in chapter 1 would be things like vertical angles. Remember, those are formed by an X, something like this. Those would be vertical angles. We also talked about adjacent angles, the ones that are right next to each other, sharing a side. We talked about supplementary angles. We talked about complementary angles. Supplementary, remember, adds up to 180, and then complementary adds up to 90 degrees. Complementary. Okay, so these are the angle relations that we talked about early on. I'm just going to try to fix that because that wasn't too good. Okay, complementary. So once we sort of went through the basics of these things, chapter 2 got more into angles, and I guess a little bit in chapter 1 we talked more about some parallel and perpendicular lines and things like that. So in chapters 1 and 2 we talked a lot about lines and angles, specifically when we have two lines that are intersected by a third line we called a transversal. Right, so remember, we saw a lot of pictures like this. We drew a whole neighborhood art project that looked like this, where we had all these different angles, and we were able to sort of talk about these different corresponding angles or alternate interior angles, corresponding or alternate interior or alternate exterior, et cetera, right? So we talked about all those different angle relationships. You can actually find those back in section 1.5. And then we talked about when they are parallel lines, all of these were congruent, or maybe they added up to 180 and so on. Okay, so lines, we talked about parallel lines, perpendicular lines, what those mean. Perpendicular, so we should have some understanding of both of those terms as well. And then we talked about measuring angles, right, in number of degrees. So we took angles Not only did we measure them, but we named them, right? We named them with 3 points, like A, B, C. We talked about the vertex of an angle. We talked about, as I said, the measure of the angle in degrees. Talked about what congruent angles meant. And then we also talked about measuring line segments in chapter 2. Measuring line segments, talking about congruent line segments with those little marks on there and so on. We also talked about bisecting. So there's a lot in chapter 2 about bisecting. Bisect, again, remember, means to cut in half, to cut into 2 equal pieces. So bisect 2 sections, 2 equal sections. So chapter 2 is all about angles, complementary, supplementary, measuring angles, congruent line segments, bisecting angles, bisecting line segments, and so on, okay? After we dealt with that, we started talking about triangles. We started moving into the world of 2-dimensional shapes, and we talked a lot about triangles in chapter 3. So we talked about naming triangles, remember, with our triangle symbol, and then 3 letters, which represent the 3 corners or vertices of the triangle. We talked about acute triangles, obtuse triangles, right triangles. We talked about isosceles triangles, equilateral triangles, all of these sort of vocabulary terms. I'm hoping we can remember sort of what they mean, or you know, the way that we can draw these triangles and so on. The third one here is scalene. We classified triangles like this, remember, based on side lengths here and angle measures up there. We talked also in chapter 3 about congruent triangles. And we talked about some shortcut ways that we can prove 2 triangles are congruent. Remember that congruent shapes in general means the same side lengths and the same angles, but triangles had a few shortcuts. We had side, side, side. We had side, angle, side. We had angle, side, angle, which is also sort of like angle, angle, side, okay? And then maybe we talked about HL. I can't really remember. This is the one just for right triangles. That one's just for right triangles. Okay, then we also talked about similar triangles and some inequalities in triangles. So similar triangles, remember, were triangles that had the same shape, but not necessarily the same size. So we might have a bigger version and then a smaller version of the same thing, right? So these might be similar triangles as long as their angle measures were the same. Okay, so we talked about those in terms of setting up proportions, right? We had missing side lengths of triangles. Let's say, you know, this is like 4, and this is, maybe that's also 4, and that's 6, and then this one was 2. So then what's this one right here? You know, we set up proportions where we went, you know, 4 goes with 2. So 4 over 2 is equal to 6 over x. And then we cross multiply and solve for x in that way. So remind yourself about proportions. That comes up in section 3.7, page 78 of your book. So you can look back at that if you're unsure. And that was the main things that we did with triangles: classifying them, naming them, congruent triangles, similar triangles, and their proportions. Okay. And then chapter 4, we moved on from 3-sided shapes to more 4-sided shapes, and we had some generalized discussions about polygons, which again just mean 2-dimensional shapes. So starting in section 4.1, we talked about polygons. We talked about angles inside of polygons and so on. 5-sided shape, 6-sided shape, 7-sided shape, 8-sided shape. You can go back and remind yourselves of those names, classifications. And then the rest of this chapter is about specifically 4-sided shapes and more specific 4-sided shapes, starting with parallelograms. Right, so we should know sort of what it means for a 4-sided shape to be a parallelogram and a couple properties maybe. And then within parallelograms, there were rectangles and also rhombuses and squares. Okay, rectangles, rhombuses, and squares. And then we also looked at trapezoids. And trapezoids, remember, have just one pair of parallel sides. Parallelograms had two pairs of parallel sides. Trapezoids, just one. Those were both called bases, right? And then the other two were called legs. And that was really it. That was really all that we did in chapter 4. We stopped somewhere right around 4.6, 4.5, somewhere in there. So that's the main things, is remembering these different types of shapes, what makes up each different type of shape, and so on. And then after we talked about the shapes, we talked about their areas and their perimeters, right? So we spent chapter 5 sort of really more like reviewing area and perimeter of these shapes. So we talked about area and perimeter formulas for rectangles. We talked about it for parallelograms. Talked about it for triangles. Talked about it for rhombuses, which is sort of like a parallelogram, and then also trapezoids. So remember, specifically for all the ones that are not rectangles, a lot of them involved the height of the shape, and it's important to remember that the height of the shape had to hit the base at 90 degrees, right? It has to hit at 90 degrees. In a triangle or in a rhombus or in a parallelogram or in a trapezoid, it has to hit those two bases that are parallel at 90 degrees in order to be the height that we use for the formulas. Right? Now, we should have those formulas in our notes somewhere. All of chapter 5 videos are on Google Classroom, so you can go back and look at those if you need to. Or like I said, go back through and review chapter 5. We did pretty much everything from 5.1 up to 5.8. And then we did talk just a little bit in chapter 6 about circles. We just spent like maybe 2 videos talking about circles. One on the parts of a circle, how it's different than bases and heights, and how we have radiuses and diameters and chords, that kind of cut across the circles like this, chord versus a diameter. And then we spent one talking about the area formula and the circumference, which is the circle's version of perimeter, right? So you can go back and look at sections 6.1, 6.2, 6.3 to review circles and their area and perimeter, which we call circumference. Okay, and then the last thing that we talked about was surface area and volume, and that's sort of what we just are finishing up. It's what we just did this week. We talked about surface area and volume, and we looked at formulas for those 5 different shapes, right? We had rectangular prisms, we had cylinders, we had pyramids, specifically rectangular pyramids with rectangles on the bottom. We had cones, and we had spheres. So each of these 3-dimensional solids, 3-dimensional figures, you should be able to use the formulas for surface area and volume to find those, remembering surface area is units squared, volume is units cubed. If you have any questions about any of this stuff, any of these vocabulary words that you can't remember and can't find in your book or somewhere on the internet or in your notes, please let me know. And otherwise, like I said, this is sort of things we might see on a final quiz. Surface area, area and perimeter, polygons, quadrilaterals, triangles, lines, angles, all these different types of vocabularies, and then of course the basics of geometry. So if you have questions, let me know. Otherwise, that's all I have for you right now. We'll finish strong, and I'll talk to you soon.